All right, so we're on to 7.2 here. Learning target is I can use a unit circle to find sides and angles of triangles on just various points along the circle, essentially. So yeah, we're going to introduce what's called the unit circle. The first part here is a little explore problem. It says a bug is placed at the point 1, 0, and it starts walking counterclockwise with a radius around a circle with a radius of 1. So basically, a bug walks around a circle, keeping a 1 distance one, they don't really give us a unit, but 1 unit from the center. Okay, and obviously if it kept going, it would make a circle. So this is how you calculate the distance along the circle that the bug has traveled. We've learned this before. This would be circumference. And circumference of a circle is, there's 2 formulas. There's 2 pi r or pi d. And both those are saying the same thing. In this case, the radius is 1. So it's going to just be 2 times 1, which is 2, or in other words, 2 pi. So 2 pi would be the distance that it travels. It also says, how can you determine the measure of the central angle? So when they say central angle, they're talking from the starting point here, what this angle is. All right. Now, there's a lot of ways you can go about figuring this out. But basically, if you calculate how far it's walked, you could divide that by 2 pi, multiply by 360. That'd be one way. You could use trigonometry to figure it out. There's kind of a lot of routes, so let's kind of move to the next question and sort of talk about what we can do. So it says, when the bug has traveled 1/8 of the way along the circle, how far has it traveled? So 1/8 of the way, if you think about it, this would be 1/4 of the way. 2 quarters, 3 quarters, 4 quarters. So this would be 1/8 would be right here. So this is 1/8 of the circle. So if the full distance is 2 pi, and we're doing 1/8 of that, right? 2 pi times 1/8 would be 2 pi over 8, or reduce that, just pi over 4. So that's the distance that it would travel on the circle, pi over 4 units. It also says, what central angle would that be? Well, you know that this would be 90 degrees if it went to here, so it's going to be half of that, so it's going to be 45 degrees. And actually, the connection we're going to make here is we've talked a little bit about degrees versus radians. This is a degree. This is actually in radians what we're talking about. Pi over 4 is the distance on the unit circle traveled that equates to the degree measure. So when we see degrees and radians in our calculator, those are actually how those are related. Same questions here for 1/6 of the way and 4/5 of the way. So 1/6 of the way, we thought of it as in terms of this, but it's really just 1/8 of 360. So 1/6 of 360 would be 60 degrees. Or 2 pi over 6, which would be pi over 3. So those are actually also equivalent degree to radian measures. And right here, 4/5. So 4/5 of 360. And if you don't know that, for some reason I'm blanking right now, we could type that in. It's 288. And 4/5 of pi, 4/5, times 2 is going to be 1.6 pi, or you could keep it as a 8/5 pi, either way. Those would be equivalent values as well. And so we can actually figure any of those things out using that concept. All right, cool. So let's move on down here. This says, what is the measure of the angle shown? All right, so we know this coordinate is at -4 and then 4√3. They want to know this angle. There's not a great way to calculate that angle based on anything we've learned. What we do know, though, is if we were to draw this same exact triangle, but if we were to draw this triangle over on this side, we could actually use trig that we've learned. This is a right angle. We could figure out this angle, and then we know those are a supplementary pair. So that would give us a route to go. So something to keep in mind. Let's read through this. It says, the angle represented by theta, so this is theta, my bad, is in the standard position. So when they draw it from your positive x-axis, they call that theta. The vertex is the origin, yep. And the initial side of the angle is the positive x-axis. So this is your initial side right here. The terminal side is where the ray goes. So this is referred to our initial side. It's almost always located in this exact position, right on the x-axis, positive x-axis. And they draw in what they call the terminal side, which you could draw at any angle, and that creates an angle. So with that said, we haven't really answered this question yet, but we're going to talk about how do we figure out this angle, which we'll name here in a second. So let's look at what we got next. There are a bunch of different ways you can name your angles. So right here, this is a positive angle. You call this 120 degrees. So I guess we can go back and show about how we knew it was 120. So let me go back to my triangle I had here. This is a distance of 4, height of 4 root 3. If you notice, those are 30, 60, 90 dimensions. So if that's the short side, that's the long side, this would be 8. We know it's a 30, 60, 90. This is the 60. This would then be the 30. So we use our 30, 60, 90 shortcuts to identify what that one is. Now, you could also take tangent and say like tangent inverse of opposite over adjacent, and you could find that angle that way. But we know this angle is 60. All the way across would be 180. So then we'd identify this angle to be 120 degrees, which is what we see on the next page there. So we see you can label this angle as a positive angle measure of 120 degrees. You can give it a negative angle measure where you go clockwise. You call it negative 240. That's the same exact ray. And then you can actually go with multiples of 120, but then add multiples of 360 to it. Because if you said 480, that's a full turn, gets you to 360, plus another 120. So if you take your angle and add any multiple of 360 to it, these are all describing the same exact angle. So there's different ways you can write these angles. Here it says, because all three of these angles in this exercise are in standard position and they share a terminal side, they're called coterminal angles. So all of these 120, negative 240, 480, other multiples, of 360 after that, are all called coterminal, meaning they have the same degree, the same angle, but the degree can be given a few different ways. Okay. So this wants us to go through, give the initial terminal sides, find the angle measure, positive angle measure, negative angle measure, and a measure greater than 360. All right, so this should be pretty easy. This is a 180 degree angle. That'd be the positive. The negative is actually also the same, but just negative 180 because we go in that direction. And then if you took this and added 360 to it, you call it 540. You could add another 360 if you wanted to. You call it 900. You could obviously do that forever. All right. So this one here is a little tricky. So this is showing us this angle, and they tell you that this part is 25. Now, if you go around, you go 90, 180, 270. Take away that 25, and this angle is actually 245. So that's the angle that's given to us. As a negative angle, if you subtract that from 360, that'd be 115. So negative 115 would describe the same exact position. Or you could take 245, you could add 360 to it in as many times as you want. You can come up with more and more of that angle. So 605 works as well. And like I said, you can keep going if you wanted to. So there's the positive, the negative, and other greater than 360 values. You can keep going. All right, so just realizing those are all equivalent, all basically the same thing. All right, now we have what's called a reference angle. It says, what is the reference angle for a 130 degree angle? Okay, when the angle is in standard position, the reference angle is the acute angle formed between the terminal side, which is this side, and the x-axis. So this right here is our reference angle. I don't know if that's a terrible arrow, but reference angle is always the acute angle. All right. Now, if your angle was right here, then this side we'd call it the reference angle. So basically, it's the half of the angle that's smaller than the other one, out of the 180 there. All right. So in these cases, it says to find the reference angle for any angle, first sketch the angle by considering the quadrant and the terminal, which lies the terminal sides. Basically, recognizing that if it's between 0 and 90, it's going to lie here. Between 90 and 180, it's going to lie here. 180, 270 is going to be here. 270, 360 is going to lie here. Okay. So a 130 degree angle in the standard position has a terminal side lying in quadrant 2. You could then subtract it from 180 to figure out that it is a 50 degree reference angle. All right. So that's the big takeaway here, is that when they talk about reference angles, they're talking about it from the x-axis, the angle that it would make the smaller acute angle, not the obtuse angle. All right. So what's the reference angle for a 210? So that'd be 180, and then so 210 is going to be like here. All right. So if you have 180 degrees to there, this is going to be 30 degrees. So 30 degrees is going to be our reference angle. Okay. And It says sketch the angle, determine the quadrant it lies in. So it's obviously in the third quadrant. Cool. Reference angle is 45, and its terminal side lies in quadrant 4. 1, 2, 3, 4. So if it's a 45 here, all right. What are a positive angle measure and negative angle measure for the angle? So the positive would be 90, 180, 270, plus another 45. So that's 315 degrees, or negative 45 degrees. That'd be the positive and the negative giving you that same degree. Again, positive goes counterclockwise, negative goes clockwise. That's how it's defined. Give a positive angle measure and a positive negative angle measure for each of these reference angles. So 10 degrees in quadrant 3. 1, 2, 3. So it's here. 10 degrees. Okay. So they want us to give the positive and negative. So positive would be 180 plus 10, so 190. Going in the negative would be a negative 170. Okay. Here, 15 degrees in quadrant 1. 15 degrees. So its positive would just simply be 15 degrees. Its negative would be going all the way around here. So it's going to be 360 minus the 15. So it's a negative 345. Okay, so again, positive is going starting from here, going counterclockwise. The negative starting from here, going counterclockwise. So those are two different angles we're always talking about when they talk about the positive and the negative. All right. On to example 3. It's your last one. So we have a picture of the unit circle we talked about earlier with the little bug problem. So unit circle has radius 1, and 1 goes all the way around, -1, -1, 1. Those are all points on it. And you can draw a triangle anywhere in here. Depending on where this ray goes to, you can construct a little triangle with a little x and a y. It's got your angle here, your reference angle that we've talked about. So that's kind of fits into this. And so it says, based off trigonometry, you can use, like whenever you draw a triangle in here, you could say sine of theta is going to equal y over 1, or cosine of theta is going to equal x over 1, because the hypotenuse is always 1. That's the beauty of the unit circle. Basically recognizing that sine theta always just equals y, and cosine theta always equals x. So this is going to be cosine theta, this is going to be sine theta every single time if you're working to solve. It's like a nice little shortcut. So it says an angle has a measure of 60 degrees and a terminal side that intercepts the unit circle at xy. So just saying the terminal side crosses at xy, basically exactly what's described there. What are the values of x and y? So you've got a 60 degree angle, so 60 degree. This coordinate is xy. In other words, this is x and this is y. So the question is, what are the values of x and y? So we already know cosine of 60 is going to give us x, and sine of 60 is going to give us y. We can type those in our calculator, or we can even remember these like from our, and I'll type them in, but then I'll tell you that you actually just know these from your value. So it's 1/2 or 0.5. Because remember, this is 1. This is a 30, 60, 90. So half of this value, half of 1 is 1/2. Makes sense. This is going to be 1/2 times root 3. So when we go to type that one in, you're going to see that's 1/2 times root 3. In other words, root 3 divided by 2. You'll see it's that same exact value that we've seen before. Okay. Last piece, this one says, what if it's a 45 degree angle? All right, same everything else. So again, we can draw our picture. We know it's a 45 degree angle. We want to find x and y. So we know that cosine 45 is going to give us x, and sine 45 is going to give us y. So cosine 45 is that, sine 45 is the same thing. And if you remember, if this is 1, this is going to have to be root 2. So these are both root 2, which is exactly what that 0.707 number is. Because remember, it's root 2 times, root 2 over 2, my bad. Misspoke there. Because we take half of this value, multiply it by the root, or think of it as, what would you get if you took root 2 and multiplied it by root 2? You have to divide it by 2 to get to there. So you can get the radical values. You can also get the decimal values. That's the real key here to starting with the unit circle.